Definition of software-defined security. Software-defined security is a type of security model in which the information security in a computing environment is implemented, controlled and managed by security software. It is a software-managed, policy-driven and governed security where most of the security controls such as intrusion detection, network segmentation and access controls are automated and monitored through software. Example: software-defined security is typically implemented in IT environments that have minimal or no hardware-based security dependence, such as cloud computing and virtualization infrastructures. Each new device created within the environment is automatically covered and controlled under the base security policy. This also ensures that the security reach and scalability of the underlying environment moves with the increasing infrastructure, environment resources. Moreover, being software-defined and managed security, environments can be moved or migrated within other data center, IT facilities without affecting the security policy and controls in place. Software-defined security architecture. Physical layer, control layer, application layer. Physical layer. This layer is also known as the data layer or base layer since it is at the bottom of the three-tier hierarchy. It contains hardware forwarding devices such as switches, routers, virtual switches, and access points. Control layer. This is the brain or the core of STS since it handles all the control and management operations. All security mechanisms are abstracted from the security devices and set inside the controller in the control layer. Security solutions that are normally implemented in control layer include antivirus, firewall, anti-spam, and intrusion prevention system. Application layer. All applications reside in this layer. It contains SDN applications. Network security techniques can be deployed as applications in this layer. To be effective, security must be built into the architecture and must protect the availability, integrity, and privacy of information. STS would be more secure because many breaches are due to misconfigurations of security products. Application of software-defined security. Abstraction, automation, orchestration, scalability, API enabled. Abstraction. Abstraction makes security independent of physical devices like firewalls. Instead, the security relies on policies that are applied across all assets, regardless of their physical or virtual nature. This device independence allows security and compliance requirements to be applied to cloud deployments as well as local data centers, ensuring required security measures are implemented everywhere consistently. Automation. STS allows deployment and configuration of security controls with little human interaction. Security policies travel with devices and applications, so security measures don't need to be redefined if an asset is relocated to another data center or to the cloud. New devices can be automatically covered by the base security policy. STS detects and automatically responds to security events, generating alerts and isolating devices depending on policy specifications. As a result, human error is reduced. STS also lets network administrators focus on complex tasks like planning and understanding future threats, rather than on more routine tasks like configuring firewalls. Orchestration. Rather than managing every network security control separately, STS integrates intrusion detection, network segmentation and monitoring into a single platform that oversees all those security functions. This integration of controls makes it easier for companies to satisfy the control requirements of various compliance standards and provides security administrators with much greater visibility into the network. In addition, the orchestration features of STS streamline the process of adding new devices by integrating security management with hypervisors and other platforms. Scalability. Modern data centers and cloud computing are designed to be scalable, with VMs that can be spun up on demand. As a result, security needs to spin up on demand as well. Because STS implements security through software, it is easily and automatically applied as needed. API-enabled. STS provides access to its security monitoring and control functions through APIs that allow the STS functionality to integrate with any other tools that the security team requires. APIs enable STS to be aware in real time of infrastructure changes that affect the way policies are applied and allow access to fine-grained features in order to modify individual security controls as well as the functionality of the orchestration platform. Through APIs, STS offers companies flexibility to adapt their security to new demands rather than locking them into a specific model of protection. Benefits, advantages of software-defined security. Simplicity, scalability and flexibility, cost-effectiveness, increased security, security threats and attacks, use of existing network appliances. Simplicity. In physical data centers, security architecture is complex. It often requires multiple servers, specialized hardware devices, network identities, and more. In a software-defined model, security is based on logical policies. We like to equate this to mathematical walls replacing the physical walls of a data center. STS does not rely on physical location of data. Information may be protected anywhere it resides. Scalability and flexibility. Nearly any type of virtualization adds elements of scalability and flexibility. In the world of security, removing hardware from the equation makes it quick and easy to scale security up or down based on the immediate needs of each host hypervisor and each business. Also, geography becomes irrelevant in securing networks with devices in multiple locations. As companies migrate assets to software-defined cloud infrastructures, the security to protect these assets needs to also shift to the software-defined model. In a sense, STS is security in the cloud, for the cloud. Cost-effectiveness. Because virtualizing security eliminates the dependence on and need for hardware that is expensive to buy, upgrade, and manage, STS is a cost-effective model that can be consumed in an as-you-go model. Thus, users pay only for what they use. The heavy capital expenditures are eliminated. Increased security. Perhaps the most controversial benefit of STS is that it offers increased security. Hardware enthusiasts will argue that there is nothing stronger than the sticks and bricks of the physical data center and the metal of the hardware devices. But this is not necessarily so. Mathematics, and especially when mathematical proof is available, is more resilient than hardware. And some companies, with limited resources, cannot create the kind of physical security that STS offers. Security threats and attacks. Since their mitigation can be applied close to the source of the attack, organizations can relieve their network from having to off-ramp traffic to a central location and allow for dynamic insertion and removal of security points where and when needed. Use of existing network appliances. Even if legacy appliances do not support advanced traffic monitoring mechanisms, organizations can aggregate the legacy functionality via the SDN controller and blend this with other new technologies as they are introduced. Illustrative Example. These are some of the companies offering solutions and offerings for software-defined security. BlackBerry, Cisco, CrowdStrike, FireEye, Fortinet, McAfee, Palo Alto Networks, Symantec, VMware, Zscaler.